Nearly 71% of the Earth's surface is made up of water. You can find the 7.5 billion people that make up Earth's population on the continents and islands that make up the other 29%. What happens in the water does not stay in the water when it comes to the weather and the climate, so the oceans are the focus of this week's Earthbeat as we continue our chat about climate.
If you turn up the sun, or you turn up CO2, or you quit blocking the sun with volcanoes, or if aliens came by with giant laser space rays and you make it hotter, that causes other changes in the Earth.
If I tell somebody to close their eyes quick and tell me the very first thing that comes into their mind when I say climate change, what is it? Usually, it's a polar bear. It's a polar bear that looks skinny, it's on a little piece of ice, it's floating in this big blue part of water. But you know, if you're looking for messages that really resonate with people, you're looking for messages that are emotional, or personal, or relatable. So I think in large extent, and it's not anybody's fault, but the default image of climate change has been something that really doesn't relate to most people. So what does relate to people?
Things that directly affect us tend to get our attention faster, and at this time of the year, hurricane season certainly comes to mind.
We've known for a long time that the intensity of tropical cyclones has the potential to get stronger in a warmer world. And that's because when you have warm ocean temperatures, that provides the energy source for the thunderstorms that drive the tropical cyclones. The thunderstorms are very active. So if the ocean temperature's warm, those thunderstorms get even more active, storms can get even more intense.
Back in the mid-1980s, Dr. Kerry Emanuel at MIT was researching the mechanisms that work to intensify tropical cyclones. He developed a theory, a theoretical number based on equations that govern these systems as to how strong they have the potential to get. That theory has been widely accepted for over 30 years, but in the last few years, Dr. Jenny Evans decided to revisit that theory.
And Alex Kowaleski, who's the newest Penn State PhD, published a paper. We published a paper in 2016, and what we did was to say, well, really that energy is going to be translated to the storm all the way in as the air spirals in to the center of the storm more and more. And by taking that into account, we found that the maximum intensity a storm might reach was even 1 or 2 categories more intense than what the current theory would predict.
So we have suggested that warmer sea surface temperatures can fuel stronger tropical cyclones. There are other implications of warmer sea surface temperatures. Let's revisit the ice.
That you put warmer air over the ocean, it picks up more water vapor. Your hair dryer has a heater for a reason. And that water vapor is also a greenhouse gas. So warmer, you get more water vapor. It gets a little warmer still. Warmer, it melts snow and ice. Snow and ice are highly reflective. When the sun hits them, it bangs back to space without heating us. When you get the snow out of the way, then the sun can warm us and we get a little more warming.
Now, a lot of this snow and ice will grow and retreat annually. It will snow a lot in the winter, it will melt in the warm season. That oscillating behavior is to be expected. But there is also a lot of snow and ice that has been on land for a very long time.
And if you melt that, you get more warming, but you also get sea level rise because the water ends up in the ocean.
One of the big things relating to tropical cyclones, but also to the coastal US in general, is the impact of sea level rise.
So my recommendation to the Navy is that yes, we need to look at the Arctic really first and foremost, but the changes in the Arctic were simply a harbinger of these broader changes to come. And that's why I recommended and the Navy accepted that we initiate the Navy's Task Force on Climate Change, which I'm happy to say to this day is still in existence.
Some areas of the coastal United States are already seeing the effects of slightly higher seas, such as Florida.
In southern Florida at the moment, there's been measurable sea level rise, and there are cities there that are experiencing what they call clear sky flooding. So it's not raining, But because the ocean is higher, it bubbles up through the drains, and people actually have water around their feet when the sky is nice and sunny and clear.
And if you think about it, human civilization itself is only 10, maybe 12,000 years old, 8 to 12,000 years old. And that is the time that we've actually been in between ice ages. And we've had this remarkable period of natural climate stability. So although cavemen didn't say, hey, our climate's stable, let's start agriculture. I don't think that's what happened. But what we realized is that if we grew something in a certain place, it would more or less grow there every year. If we started setting up ports on the Mediterranean or in the Persian Gulf, the sea level was pretty much stable, and we didn't have to keep either having that city flooded or move it another 5 miles because the ocean fell. We had stability, and we've really built human civilization on stability.
If the background state of that stable climate gets changed, some of our habits need to change. We will talk about adaptation and mitigation in part 3. We'll have that for you in a couple of weeks. For Weather World, I'm Ben Reppert.